Hello class, and welcome to day 1 of section 1.4, which focuses on literal equations and formulas. By the end of the lesson, you will be able to rewrite equations to solve for a specific variable, as well as apply those rewritten equations to solve problems. A formula is an equation that relates two or more quantities in a specific expression or relationship. So for example, you're very familiar with area formulas. Those are something that are used specifically to find out how much space is inside of a particular geometric shape. Literal equations are equations that use more than one variable to stand for unknowns and knowns. So formulas are a type of literal equation because your area formula, for example, for a rectangle, is area is equal to base times height. We've got multiple variables standing for things that we know and we don't know based on the problem's information. So one of our goals here with literal equations is to be able to rewrite them to solve for a specific variable. So in this case, I've got the same equation on the left and the right side of the slide. We're going to solve for the two different values. So, starting on this left side, we're trying to solve for n, aka get n by itself. You use the same rules of SAD-MEP, you just won't be able to find an actual numerical example. So in order to get n by itself, I need to get rid of this plus 6. In order to get rid of adding 6p, I'm going to subtract 6p. Now, we all know that we can't actually combine 15 with 6p, so we just write it out as 15 minus 6p, and then that's going to still equal 3n. So we can't actually put these together to get number answers. We're just rearranging the equation. Then in order to get n by itself, I'm going to divide both sides by 3. When we're doing this now, if this was a 7, for example, we couldn't simplify this any further. But because we're dividing by 3, we can simplify. 15 can be divided by 3 and give me 5, minus 6 can be divided by 3 and give me 2. And then I've got my n left over on the other side. So when we rearrange this equation to solve for n, we end up with 5 minus 2p is equal to n. On the other side over here, now we're going to try and solve for p. So the first thing we want to get rid of is the 3n. Still going to subtract. We still can't combine that with the 15 because 15 is a number and 3n is a variable quantity. So we're going to have 15 minus 3n. Then I need to get rid of that 6 in front of the p. So I'm going to go ahead and divide the sides by 6. Now, we can't find a numerical answer, but we can reduce these quantities. All of these values can be reduced by 3, so I'm going to end up with 5 minus 1n, or just n, over 2 is equal to p. So we've taken the same starting equation and rearranged it to solve for the two different variables. So the goal is, and the thing that you need to pay attention to, is which variable are you solving for? Go ahead and solve this equation for variable g. Subtracting 4y and then dividing by 8. You can't reduce this because all three of them cannot be divided by the same number. So you have 37 minus 4y over 8. Sometimes the variable you're going to solve for appears more than once. So in this case, x is what we want to solve for. We have an x on the left side of the equation and on the right side of the equation. So the first thing we need to do is get all of those x's together. It doesn't matter which side you move them to. I'm going to go ahead and move them to the left side. So I'm going to take positive xz and I'm going to subtract it from both sides. So now my equation reads 3x minus 2y minus xz is equal to 5. Again, we're solving for x, so anything that doesn't have an x, we need to move out of the way. In this case, that's the negative 2y. So I'm going to go ahead now and add 2y to get rid of that value. And my equation now says 3x minus xz is equal to 5 plus 2y. Now, there's an x in each part of these. So we need to pull that out or reverse the distributive property. So I'm going to take the x away from the 3x, which leaves me with just 3. Then I'm going to subtract. I'm taking the x away from the xz, which leaves me with just z. And then we've got 5 plus 2y. So we took out the x from the two pieces that had x. Now, we know that distributive property means multiplication. So in order to get rid of multiplication, we're going to divide by the whole thing in the parentheses. So divide by 3 minus z, giving us a final answer of x is equal to 5 plus 2y over 3 minus z. So we rearranged and got the variable that we wanted to be on the same side of the equation, moved everything else to the opposite side, used a reverse distributive property to pull that variable out to be its own thing, and then divided by what was left over. Go ahead and try this one on your own. Again, make sure all the variables we want, in this case a, are on the same side. Use that reverse distributive property and then divide. Sometimes we rewrite equations in order to be able to solve specific formulas. So for example, Juan is rearranging the equation for the volume of a cylinder, which is V is equal to pi r squared h, to solve for the height. How should he rewrite the equation? So our goal here is to get the height by itself. Our equation currently says that V is equal to pi r squared h. If we want to get rid of everything except for the h, we're going to need to divide by pi and r squared. So this one was relatively simple, and we find out that volume divided by pi r squared is equal to h. So this would allow us to plug in a lot of different numbers and find various heights. Go ahead and try this one on your own. Rearranging to get the principal by itself, we have to divide by the rate and the time. So we get interest divided by rate times time equals principal. Now that we've rearranged formulas, we're going to talk about how we can use those rearranged formulas. So in this case, in a half an hour, Sarah is meeting her friends at Bde Makaska, which is 6 miles away from her house. Using the formula distance equals rate times time, find the average speed in miles per hour, she must ride her bike in order to get there on time. So we are trying to find speed, which means that we need to rearrange this equation to solve for the speed part. So it starts with distance equals rate times time. Our rate part is the r, so we're going to divide both sides by t and find that our rate is equal to the distance divided by our time. Now we can use this new equation, this rearranged equation, to find the value for the problem. So we know, in this case, we're finding the rate. Her distance is 6 miles, and her time is a half an hour. Since we want it in miles per hour, we need to use 0.5 as our time, because that's the amount of an hour she has. And we find that our final answer is going to be that she needs to travel at 12 miles per hour in order to reach her destination on time. Go ahead and rearrange the distance formula in order to answer this question. Again, we're solving for the rate, so dividing by time, plugging in the values that you need, you find that this one is 10 miles per hour. Last thing, we're going to just do one more example with this rearrange and apply. So Tom is framing his Torrey Hunter Twins jersey. He knows the perimeter of the frame is 144 inches and the width is 40 inches. If the perimeter formula is P is equal to 2 times the length plus 2 times the width, rewrite the equation to solve for the missing value. So we have a perimeter given to us, and we have a width given to us, which means that the missing value here is our length. So our first job is to rewrite our equation to solve for length. So I've got perimeter is equal to 2 times length plus 2 times width. In order to get the length by itself, I'm going to subtract the 2w from both sides, which says perimeter minus 2w is equal to 2 times the length. In order to finish solving for length, I'm going to divide both sides by 2. And I get that length is equal to the perimeter minus twice the width divided by 2. Now that we have our rearranged equation, we can go ahead and plug in our values and say that the length is equal to the perimeter, which is 144, minus 2 times the width, which is 40, dividing by 2. Continuing to solve this equation now, we are going to go ahead and say length is equal to 144 minus 80 divided by 2. 144 minus 80 divided by 2, when we plug into our calculator, is going to give us 32 inches as our length. Go ahead and rearrange this area formula and try this one on your own. Rearranging for the height, you're going to have twice the area over the base. Plugging in your given information, you find that for this particular triangle, the height is 4 inches. If you have questions about this or anything else from the lesson, please let me know when you get to class.